Hi guys, and welcome to this tutorial. In this tutorial, I plan to explain some of the concepts behind aspect-oriented programming. We'll try to understand how and why aspect-oriented programming works. Well, if you think about this in a pure object-oriented sense, let's take this main example. If you look at it in a pure object-oriented sense, I am calling a method of an object, and that method has some code which is already in it. Now this code has to run whenever I call this method. Now how is it possible that some other code which is in some other class, in some other method, runs when I call this method? How is it even possible? Now I have an aspect configured over here, and this advice needs to be applied based on my point get definition. And now if I apply my point get definition to this method, this code will run whenever this code runs. It could be before or after or around or whatever, but this code runs even though we do not have this call to that method anywhere in this code. Now how is it possible in a pure object-oriented paradigm? Well, it's actually not possible, and as I said earlier, aspect-oriented programming is a completely different type of programming. And what we do in Spring is we use some of the object-oriented concepts to achieve aspect-oriented programming. And the way Spring uses these concepts is using a proxy. Now, we have heard of proxy as a design pattern. So what we do is, instead of making a call to class A, we make a call to class B, and class B internally makes a call to class A, but then it also adds some additional functionalities. And this is something that Spring is doing behind the scenes for us. And actually, it's not just Spring. I have made another tutorial in Hibernate series where I talk about how Hibernate uses a proxy object in order to get dynamic fetching of data. So Spring is one of the frameworks that use this, and we'll have a look at how Spring manages to implement all these different features using a proxy object. So I'm going to write and demonstrate some code now, and looking at that code should give us a good understanding of what's happening behind the scenes when it comes to Spring AOP. So let's look at this getBean. We are doing a context.getBean, and the context is behaving as a bean factory. So we give the information about what bean we want, and then the getBean method is going to give us an instance of that bean. Now, let's say we have to implement a factory object. Now, how would it work? What would we have to do to implement a getBean of our own factory service? Let's quickly try creating a factory service class. I'll call this factory service. And now let's say I have a public object getBean. So I have my own getBean method that returns an object. So what would this getBean have to do? Now let's say I have a string input argument. I have a bean type that takes information about what is the bean that we're actually looking for, and it returns an object, an initialized bean. Now I could, looking at the bean type, create a new bean. So let's say I have only a shape service, and I have a circle and a triangle. Now it could be as simple as a very primitive implementation. If bean type dot equals shape service, return new shape service. It's as simple as that. Now I'm just looking, this is all hard-coded here. A true object factory would not be hard-coded, but just to show this as an example. Now I would check if the shape service is the bean that's being requested. I would create a new instance of the shape service, and then of course I'll check for circles, say. Now if the name of the bean is circle, I'd create a new circle bean. And if the name is triangle, I'd create a new triangle. Now, of course, I'll have to import these two. And then since I'm returning an object, I'll return null here just to keep the compiler happy. But I plan to use only one of these three strings in my example, so it should return an instance of these three classes. Now, a way an actual factory would work is instead of hard coding these values, you'll probably look it up from a configuration file or some other configuration. For our example, this should serve the purpose. So depending on whatever string I'm going to pass, it's going to return an instance of each of these classes. So let me save this. And now what I'll do is, instead of using the application context getBean, I'm going to create a factory service instance, and I'm going to use that to get a bean. Let me come in these two lines of code here. So I'll say factory service equals new factory service. And then over here, shape service is, instead of using the context, I'm going to use the factory service. Get bean, and I'm going to pass shape service. Now this will return me an object, so I need to cast it. Casting to a shape service. Now if I do a shape service.circle, it'll run a get circle on a newly instantiated bean called shape service that it's returning from the factory. Now I'll just add a line of code to the get circle in order to print something out so that we can see that running. Circle getter called. Now if I save and run this, you will see that the getter has been called. Now what we are seeing here is an instantiation of an object that we have done ourselves. We are not using Spring, so none of the the Spring XML or the aspects, none of these are coming into play here. It's our own factory service which initializing a bean, and then we are calling a method of that bean. And that's it. Believe it or not, we have an implementation of a factory service. Well, it's very simple, and then we have hard-coded the instantiation, but then there you go. This is it. This is all it takes to create a factory service. You just have to move these instantiations and configurations to a separate file, and you have a pretty much full-fledged factory bean. Now, having implemented a factory service, we'll have a look at a primitive implementation of aspect-oriented programming here. Now, let's say I have a get circle as a target method, and I want a separate method, an aspect method, say, to be called whenever a get circle needs to be run. Now, how would I do that in my primitive implementation of a factory bean? Now, let's say I have a separate class over here, or let me use the same class. This is after all just a plain bean. We don't have any aspects over here. Now, let's say I have a public void logging advice. Then I will do a sysout logging from the advice. Okay, so this is just a plain Java method inside a simple Java class. Now I want this logging advice to be executed whenever I run a get circle on my shape service that I've got from the factory service. How would I do that? Well, the way Spring works is by creating a proxy object. So let's try creating a proxy object over here. Now I know that the bean that I need to pass back whenever a get bean of a shape service is called has to be of type shape service, because I'm casting it to shape service and I'm assigning it to a local variable over here. So the return type of this getBean shape service has to be of type shape service. So what I do is, to add extra functionality, instead of returning an instance of this class shape service, I extend this class and then I return an instance of that subclass, which will be an extension of the shape service class. Now I'll just implement it so that it gets simple. So what this actually means is, I need to create a new class that extends this shape service class. Now I call this shape service proxy, and this has a superclass as shape service, and finish. Okay, so what I do is, instead of returning an instance of shape service, I return an instance of the shape service proxy. Now let's change that over here. I return an instance of the shape service proxy. And now, without doing anything, without adding any code over here, then what happens if I execute this? Now what if I get the shape service proxy, but I'm casting it to a shape service and I'm putting it into a variable here, and I'm calling a get circle. Now what happens? It still calls the same method because I have not overridden any methods over here. Now even if I override a method over here, let's say I override the get circle from the shape service. Let's say I override this. But what I do is, I do not add any code over here. I just refer to the super. So I'll say return super dot get circle. So all I'm doing is, I'm just saying, hey, I'm not going to implement any code over here. All I'm doing is I'm calling the get circle of the super, which is the shape service get circle. Okay, so now what happens if I run this? It is still the same. So what I'm doing here effectively is, I'm giving a proxy class as a return to the main. The main does not know it. The main thinks that it's a shape service, and that's all it cares about. It just needs to execute a method of the shape service. So instead of returning an instance of the shape service, what I do is I create a proxy class, and then the method of the proxy class just calls the super. So it behaves as a shape service. It's disguised as a shape service, but it is not shape service. It's a new class, and I'm creating an instance of that in my factory. So this is essentially what Spring AOP does. Now you might ask, what is the advantage of doing this? Why not pass the shape service itself? What's the fun in creating a new class and then getting an instance of that class to return and not the original class? Well, the beauty of this is, since I have a new method here, I can actually make additional calls before I call the target method. Now this is similar to what we saw in the around, right? We had a new method, and then I could call the target method whenever I wanted, and then I could write code above or below. Well, you can do pretty much the same thing over here. Now I have one line of code in this method which calls the actual get circle. This is what calls the actual get circle, not this. I'm just calling the get circle of the proxy here. So what we can do is, here I can actually make a call to my logging advice. Let's do that. Here I call logging advice of the logging aspect. So let me initialize that. New logging aspect dot logging advice. I will import this. Now what's going to happen? Now from the main, I'm saying get bean of the shape service. What the factory service does is it returns a shape service proxy, which is this guy over here. Now when I do a get circle, what gets called is the get circle of the shapes, the shape service proxy. And I make a call to the logging advice in this proxy, and then I do a get circle. So this is effectively doing a before advice. So this acts as a before. So this gets executed before the actual call to the target method. And every time you run a get circle to this shape service, which is actually a proxy, every time you run a get circle, you can be sure that this method is going to run, the get circle of the proxy is going to run, and then the logging advice is going to run every time you run this get circle. So let's test that out. Here you can see the logging is run and then the actual target method is run. So this is our own implementation of before advice. So you can see how simple it is. Of course, we have taken away a lot of the intricacies. This actually happens dynamically in Spring, but then here we have to statically write the code. But then this whole exercise is to give an idea about how Spring actually manages it behind the scenes. There's a lot of good material available in books as well as in the official Spring documentation that explains these concepts in theory. It explains about proxy objects and how it encapsulates the actual target method of the actual object. And after going through this tutorial, actually looking at our own simple implementation of a factory bean that returns a proxy object, I hope the concept is clear about how Spring implements aspect-oriented programming using these proxy objects.